3.4 is about scatterplots and correlations. We want to be able to say what a scatterplot is, talk about the correlation, the slope, and the y-intercept. So a scatterplot is a set of two plotted points that shows the relationship between two sets of data. So here we have examples of scatterplots. Notice they're really just coordinate planes, so x and y axes with a bunch of points on them. So here we have our two sets of data would be our height and our weight, right? So that's the two sets of data, and this scatter plot shows that the relationship is as the height is increasing, the weight is also increasing. We have this thing called the correlation that tells us about the relationship between two data sets. A correlation can be positive, negative, or no correlation. So if it's positive, that means that as x is increasing, y is also increasing. And overall, our graph is going up or in a positive direction. Negative is as x increases, y is decreasing. So overall, we have this decreasing or negative direction. No correlation, if you're looking at our dots, they are completely random. So there's no relationship between our x and our y. So we want to be able to draw a scatter plot and describe the correlation as positive, negative, or no correlation. So we're just going to plot all of these points. Remember, for your ordered pairs, it's always x and then y. So if we wanted to graph this first point, negative 5, 6, we'd start at our origin. We'd go to the left 5 or negative 5 and then up 6. So here's what our scatter plot will look like when we finish graphing our data. So we want to be able to say, is this positive, negative, or no correlation? So notice that our data isn't in a perfect line, but we're going to use something called the line of best fit, which is basically this imaginary line going through your data. So I'm going to draw this highlighted line to represent this imaginary line. And this imaginary line says, well, overall, it might not be perfect, but overall, if we're looking at our data, it looks like as x is increasing, y is decreasing. In other words, it looks like we've got a negative correlation. We also want to be able to talk about the slope. So remember, that's the rate of change. It's the change in y divided by the change in x. This remember, means our rise over run. So when we're talking about the slope, we're going to talk about it in a sentence. We're basically going to use these sentence frames, okay, to describe, well, as x is increasing, y is increasing, or as x is increasing, y is decreasing. So this is how we're going to, or what we're going to use to talk about our slope. So looking at our scatter plot example, again, we're talking about the height and the weight. So it looks like as the weight is increasing, the height is also increasing. So that's how we would describe our slope. As the weight increases, the height increases. We also want to be able to talk about the y-intercept. So remember, that's the point where the graph crosses the y-axis. So we want to be able to look at our graph, and here's our y-intercept, right? Here's our y-intercept. This looks like it's the point 0 and then 34.3. So we want to be able to talk about that in terms of the years since 1995 and the hours. Well, if it's been 0 years since 1995, it's still 1995. And then 34.3 would be our hours. So we would say in 1995, 34.3 was the average weekly hours worked. And that's how we would describe our y-intercept or talk about our y-intercept. So now would be a good time to pause the video and try to answer these questions for yourself. We want to start off by describing the y-intercept of weight loss of this dieter. So let's go ahead and find our y-intercept. It's way up here at 0, 180. So 0 is our time, 180 is our weight. So if we wrote that in a sentence, we'd say at 0 weeks or so when the diet started, they weighed 180 pounds. If we wanted to describe the correlation, well, thinking about that line of best fit, overall it looks like our data is decreasing. So we would have a negative correlation, which means as x is increasing, our y is decreasing. And if we're looking at what that means in terms of this problem, as the time is increasing, the weight is decreasing. So that's how we would interpret or describe our slope. The last thing we're going to talk about is the correlation coefficient. So this is a number from -1 to 1 that talks about how strong or how weak the relationship is. When we look at our graphing calculators tomorrow, we're going to talk about the correlation coefficient as this R value, because that's what your graphing calculator will display it as. And so we have some examples here ranging from 1 all the way down to -1. So if your correlation coefficient is a positive number, that means it's a positive correlation, right? So our graphs are all increasing over here. If your correlation is a negative number, that means your correlation is negative, right? Since our graphs are decreasing. And so we talk about this as being strong or being weak. So here our dots almost look like they're a straight line, so we would call this very strong. You know, over here at 0.3, it's still a positive relationship, but our dots are getting more and more scattered, so we would call this weak or not very strong. If our correlation coefficient is 0 and our dots are completely scattered, that's our no correlation instance. And then, of course, we have our negative correlations. So, thing to remember here is that the closer the R value is to 1 or to -1, the stronger the correlation. So for our scatter plots, we want to remember or be able to describe the correlation as positive or negative and weak or strong, and we want to be able to describe that y-intercept and our slope. Tomorrow we're going to use graphing calculators to graph scatter plots. Remember to answer the questions in the quiz and click submit.